Alright, so here we're going to look at 8.5, factoring by grouping. Here's the why. Factoring is very prevalent in mathematics. It allows us to break polynomials into pieces. Factoring plays a large role in the next chapter, so chapter 9. We're in chapter 8 right now, so in chapter 9. And many more in Algebra 2. It can be very challenging for students who try to sweep it under the rug. Let me go ahead and give you some advice. Factoring is not going to go away for a very, very long time. It'll be there in Algebra 2 almost the whole year. You must know how to do this if you plan on being successful in Algebra 2. So this is not a skill where you can be like, oh, I'll kind of know how to do it and I'll just get by. That will not work. Do not try to sweep it under the rug. You must fully embrace this factoring process. And if you go in with it with the right mindset, I think you can be just fine. So what it is we just finished a section and chapter on multiplying, to where we distribute the 3 to both of these guys to get 3a plus 3b. Distribute the x in, distribute the 6y in. What we're going to look at now is, what if I gave you the answer? Could you unpull out? Could you reverse distribute that 3? Could you reverse distribute that x? Could you, on this one, undistribute both a 6 and a y? That's what factoring is going to be. It's the opposite of what we just finished doing. All right, here's how you do it. We're going to do the opposite. So it says use the distributive property to factor this. In order to factor, we're looking for the greatest common factor. And this is in two parts. It's the greatest number we can divide all terms by, and it's the greatest variable amount that we can divide all terms by. And remember, when you're dividing by a variable, that means we will be subtracting the exponent. All right. So here's what I'll do. I'm going to look at this and I have to think, what's the largest number that I can divide both 12 and 80 by? And you can think, well, what are my factors of 12? We've got, 1, 2, 3, 4, 6, and 12. So those are all the numbers that divide by 12. I need to find a number that 80 is also divisible by. And if you try 80 divided by 12 and 80 divided by 6, it doesn't work. 80 divided by 4 is the largest one that we have. So I'm going to go ahead and pull out a 4. And what that's going to change things to is this. 80 divided by 4 is 20. We've gone through and we've figured out what's the largest number I can divide both 80 and 12 by. It's a 4. You'll know you selected the greatest common factor when now this 3 and 20 no longer share any more divisors. I can't divide both 3 and 20 by the same number, so that's how I know I'm good to go. Now what you need to recognize is we have to check for the greatest variable. So when I go to do that, I'll see, okay, this guy has an m, this guy has 2m, so I'm definitely going to be pulling out a variable of m. This term has a p. This term doesn't have any, so I'm not going to be able to pull out a variable p. So we've got the 4. In terms of the m, I'm going to be able to take 1 away from both of these guys. So it's going to be 4m, leaving us with 3p plus 20m. Now here's what happened. I recognize that I had an m that I could take from both here and here. I can only take 1 though, because this guy's only to the first power. And so we have to subtract exponents. So essentially I took out a 1 from both of those m's. This is in fact the final answer right here. And the good news is that we can double check this, because now that I know what happens when I do the reverse process, I can double check by multiplying it back out. So when I multiply this back out, I get a 12m times p plus 4 times 20 is 80, m times m is 8 squared. It's right back to the original setup. So it is possible to double check these answers by going backwards and forwards through the distributive process. So what we're going to do now, before we look at the next type, for example 2, we're going to come down and try some of these. We're going to look for GCF, so both the number and the variable. For 24 and 48, both of these are divisible by 24. So I'm going to divide them both by 24, leaving me with a 1x plus 2y. And then we'll check and see, are there any variables that I can pull out of both? And there is not. One of them has an x and one of them has a y, but in order to pull something out, to do the opposite of the distributive property, they both have to have the term. So that's why that one is complete. For this one, there's 3 terms, but the same rule will apply. I'm going to go through and see, based upon all my numbers, which is a 30, an invisible 1, and a negative 6, can I divide anything? And I can't because of this 1. There is not going to be a greatest common factor of a number on this one. Instead, I'm going to focus on the variables. I'll notice that I have an m here, an m here, no m's in the third term, so I can't even pull out any m's either. But when we look at this, all 3 of these have the variable p. So I am going to be able to pull out p. Just 1 though, because these 2 guys only have 1 to give. So everything's staying the same, except I'm losing 1p amongst all of my terms. And it's going to take me to right here as the final answer. All right, we did the reverse distributive property. The only thing that was able to be pulled out of all 3 was p to the first power. And remember that you can double check this by multiplying it back in. And if you do that, you'll see you get right back to the original statement whenever I redistribute that p. So that's confirming that we have, in fact, pulled out one of our factors. If these are confusing to you, let's keep trying. The more you do, the easier this process will become, and it eventually becomes just as easy as using the distributive property was in the first place. All right, step 1. Do they all share a number we can divide by? And they don't, because this first one has a 1. There's nothing that I can divide by to help address that. So instead, we're looking for variables. Let's see that all 3 have q's. Now I do need to check and see what's the most amount of q's I can take. It's 1, because I can't take more than 1 away from this last guy. So the only thing that's going to change on this is that all the q's lose 1 degree. And it would look just like that. There's no more q's I can take out because now this last guy doesn't have any. There's no numbers I can take out because this first guy is a 1. That is a complete answer. And some of these are very basic. On this one, hopefully now that we've done a few, you can see it very quick, and maybe even in one step. You might be able to see that I'm going to be able to divide both of the numbers by 3, and I'm going to be able to take an x away from both as well, giving me 3x minus. This one's a little unique, and I want to go ahead and cover this very specifically. A lot of times when people see that this original term was 3x, and that our greatest common factor is 3x, they want to tell me that this is a 0 or not put anything there. However, that is not the case. The reason that's not the case is because we're using division. So if you think about 3x divided by 3x, the answer to that is a minus 1. And that 1 needs to be there. That way when I go back to double check my answer to get 9x squared, that 3x needs that 1 to be there so that it can land back at the original equation. And if you're uncomfortable doing these in multiple pieces at a time, go one step at a time. Maybe just divide by 3 first to get 3x squared minus an x. And then maybe you can recognize that you're going to pull an x out to get the same answer that we had previously had. So let's check out some that have a little bit of different variety to them. Let's go to number 7. The first thing I'll look for is, what's the number that I can divide all of these by? And the more you do these, the more easily you'll be able to recognize them. All of those underlined terms would be able to be divided by a 7. So when I do this, we'll get 2t cubed left over, minus 6t to the 5th, minus 7t to the 4th. And now I know that I've divided out the largest number because 2, 6, and 7 don't share any common factors. So now it's time to pull out variables. And you want to pull out as many as you can, and it depends on the smallest guy. So since the smallest group of t's is 3, that's what I'm going to pull out, because I can't pull out more than that because that term doesn't have any more to give. So now all the numbers are going to stay the same, except every t loses 3. So the first term just turns into a 2. This t to the 5th lost 3 of his t's, so now he's t squared. And then the t to the 4th goes down to a t. And the reason that this guy doesn't have any right here is because he was t cubed, but we took out a t cubed. So he had no more left over, which means it's just a 2 right there. And here is our final answer. So I encourage you to try some of these. I'm going to write out the answers for the remaining ones. I encourage you to pause this video for you to try the remaining ones and then compare your answers with what I have. So here are the answers to the remaining ones. And remember that you can always double check your work by multiplying these back out and making sure that you land back at the original expression. That's one very intelligent way to double check your work. And the more that you double check, the more you'll become familiar with factors, so I highly recommend it. I highlighted a couple terms here just to remind you that any time that your GCF is the whole term that you divided by, it does need to have a 1 replace it. So like on this one, I had a GCF of y, so when I pulled that y out, I did need that 1 to replace it because we're using division, and y divided by y is 1. Number 11 may have been tricky for you. There was no GCF of a number. 4, 28, and 7 don't share any common factors. And then you had to look and see that they all had an a to give, and they all had a b to give, and take that away from all the different ones. So all the a's decreased by 1, and all the b's decreased by 1 in terms of their exponents. So this was factoring, the beginning process of factoring. We'll continue to build on to it tomorrow. But this covered the reverse distributive property. All right, and that's all we were doing today was the reverse of the distributive property. So the opposite of what we were doing last chapter. Now what we're going to be able to explore in the next video is that how can I factor something that has 4 terms in a more specific way? It's going to have its own method called factoring by grouping.